Hello, welcome to the nVent ERICO Cadweld Virtual Rail Training. My name is John Stenonis. I'm the Regional Sales Manager for the Rail Group, focusing on transits. I've been with ERICO for 24 years.
My name is Mike Spicola, Applications Engineering. Been with the company for 47 years. Love the product. John's still in training after 24 years, so he's learning, he's doing good. So any questions you have, we're more than happy to help.
Next, we're going to talk about safety. Safety is primary for everybody. nVent ERICO recommends when you're making a Cadweld connection that you use safety glasses. Today's a sunny day, so I have sunglasses, but they're safety glasses. And gloves. The material you're working with is very hot. Depending on the property, the rail property or the job you're working on, they might require a safety vest of a specific color, hard hat, safety shoes or boots, and when prepping the rail and grinding, they might require a safety shield. You have to check what's permitted on your property. The next thing we'd like to talk about is mold selection. ERICO follows the REMA recommendations, which say nothing larger than a 250 kc mill to the head of the rail, within the confines of the splice bar. Nothing larger than a 500 kc mill to the web of the rail at the neutral axis. And later on, when we show rail preparation, we'll show how to find the neutral axis. So ERICO can make the guarantee if you follow our instructions, which are found on your mold tag, instruction print number. If you follow our instructions, we guarantee you can carry as much power or greater amounts of power through your Cadweld connection than you can through the parent conductor. The reason that's so important to the rail, because if you have hundreds of connections, or let's say thousands of connections made with Cadweld, that's going to impact system reliability. You want to keep people riding those trains because they have a high sense of reliability in that system.
We like to say we don't make connections, we live in it.
Very well said, very well said. So, as I said, you want to use the proper conductor with the proper mold, with the proper mold material. This is an engineered system. So in order to get the repeatable, same quality connection each time, you have to follow those engineering recommendations. In this case, we have a C-bond, which is 250 kc mill. This is a specific mold for that. This welder is the framework that holds the molds to the graphite molds to the steel rail. In this case, you have two choices. You have a 13-inch welder that'll hold both your right and your left, or my recommendation, if you're going around a curve or old worn rail to new rail, you might not be able to line this up perfectly. So we have welders that are available separately in a right-hand welder and a left-hand welder. That is your choice. The other connection that we're going to be demonstrating today is 500 kc mill stub bond to the web of the rail at the neutral axis. This is the mold that you're going to use for that. Again, you always want to consult your mold tags so you're following the instructions with the proper bond, proper application to the proper size rail with the correct size of weld material. After we make our stub end bond connection, we're going to want to do a straight splice or a butt splice to whatever size cable you might have. Whether it's 500 kc mill, 1000 kc mill, we can design anything. The only limitation of Cadweld, it's a gravity-fed system. You cannot weld up. So when we do the straight splice connection, in this case, we're going to be doing a 500 kc mill. Now, it's time you make a choice of one of your options. We have traditional weld material, or we have Cadweld Plus. Traditional weld material is packed in a blue tube, and it's about the consistency of sand, actually. But at the bottom of that blue tube is compressed starting powder. So when you make your connection, and you have everything set up, you're going to pour that weld material, or that sand-like consistency, into the crucible section of your mold. Then you're going to tap the blue container on the rail and it's going to loosen up that starting powder. You're going to sprinkle some of the starting powder over the top of the weld material, and the rest of the starting powder is going to go on the lid of your mold. When we talked about safety earlier, it's very important that you use these molds. They're there for your safety. If you have an exciting reaction or something might happen, it's going to contain that reaction from you. So once you have your starting powder on the lip, as Mike just demonstrated, you're going to start a chemical reaction with a spark, very similar to the spark from your barbecue grill at home. So that's traditional weld material. But I should mention that this is PB weld material. Weld material is specific, PB is specific to the rail. So whether you're doing a grounding connection or a connection to the rail, anything used on a rail property should be PB or rail specific material. And what is rail specific material? We follow the ARIMA recommendations, which say when making connections to the rail, there should be no tin in your weld material. F20 or traditional grounding material, that has tin in it. F80 or PB material does not have any tin. It's very important to remember. So that's traditional weld material. The second type of weld material is called Cadweld Plus. I love Cadweld Plus. Cadweld Plus is an electronic system. It's safer, and I'll explain why here in a minute. But as I mentioned, you want to use a specific size weld material for each mold, and it's on your mold tag. For this C-bond, that's going to take a 90-gram connection, or PB90. So we have a specific Cadweld Plus cup of PB90. Two things to notice: PB material has a yellow dot or color inside. The outer ring is colored, in this case it's gray. So each color is specific to a size of weld material. And for people like Vinny Testaverde that's colorblind, we also have it embossed. It specifically says plus 90 weld material. So we have you covered. For the straight splice over here, that's going to take PB 200, which is right here in blue tube. But here in Cadweld Plus, it's got a yellow ring around it, but it's also embossed on it. For the web connection, that'd be PB 250 in traditional, or PB 250 in Cadweld Plus, which has a purple ring around it. Also, for quality control purposes, this is embossed with a lot number. Every time we make a lot of weld material, we retain samples and it goes through testing to make sure it meets the quality control requirements. So when you have a Cadweld Plus cup, you just drop it into your crucible. You're going to hook up a impulse Cadweld Plus ignition unit. It hooks right onto the copper tab on your Cadweld Plus cup. You're just going to press a trigger, and it's going to build up a charge, and it's going to send a spark inside that cup, which is going to get the weld material to flash up over 4,000 degrees. You're going to get the same connection that you do with traditional. It's just a safer system in the respect that once you have this connected, the operator can stand back 6 or 15 feet, whatever you may desire. So it's going to remove the operator from the reaction. You're going to get the same result as you do with traditional or Cadweld Plus. Cadweld Plus is just a different, safer method.
There's a safety feature on the unit that when you pull the trigger, it doesn't automatically ignite the plus cup. There's a time delay on it. So if you start pressing the trigger, basically what happens, you're charging your capacitor, and it takes usually 3 to 4 to 5 seconds, depending on the battery life, to actually fire it. But it gives you a little bit of time before it actually fires. Safety features, you kind of look around, make sure there's nobody around you, nothing in the way. So it's just a good safety feature of the unit.
The first connection we're going to be making is a 500 kc mil stub end to the web of the rail. And if you were listening earlier, the ARIMA recommendations say where to the web of the rail? Neutral access. So how do we find that neutral access? First of all, we want to make sure we're using the proper mold for the proper application, so we want to consult our mold tag. This is a 500 Ropelay stub end bond to the web of the rail. So to find your neutral axis, you want to put your mold on there and you want to make it snug. This is a splice bar, and if you notice there's a bolt hole in this splice bar. That is at your neutral axis. So you want to line up the middle of your nugget, which is going to be this bottom bolt. You're going to line that up to the midline of this bolt. What that'll enable you to do now, once your mold is adjusted using these adjustment screws, up or down, then you can lock it in place. Now every time you go to a new location, you're not going to have to adjust it every single time. It is set in a neutral axis for this size rail. Now, if you're going from a new rail, as you see, to a worn rail, then you may have to readjust your mold, so keep that in mind. So, as I said, using these adjustment screws, I had already located my neutral axis, and if you tighten these screws and back up on a second set of screws, you lock that mold in place. So that's one way to find your neutral axis, which is pretty easy in my opinion. The other way, which is not quite so easy, is to make yourself a template. So when you put that template in there, it's going to make a little mark. You can see where your neutral axis is going to be. That's more time consuming and a little bit more difficult, but you do have those two methods available to you. Now that we found our neutral axis, the next thing we want to do is grind the surface or clean the surface. This is vital. You want to use an approved grinding wheel. ERICO has approved grinding wheels in our offering, but if you have another grinding wheel that you want to use, please send it in. We'll be happy to evaluate it. This wheel that we offer, it's both a cutting wheel and a grinding wheel. This wheel is designed to clean your surface. We're not digging to China. We just want to clean the surface. So if you use a traditional wheel that comes with your grinder, that's used for metal shaping. We do not want to change the profile of this rail. We do not want to compromise the integrity of the rail. We want to clean the surface. So you must use an improved grinding wheel. So now, again, now that we've located our neutral axis, I want to clean a surface that we're going to be making our Cadweld connection to. So you can see I now have a nice clean shiny surface. That surface is probably good for a couple hours, but if you go to lunch and you're gone and you come back, you want to regrind that surface because oxidation can occur within a very short time. Now we want to put our mold up to the rail and make sure that it's lining up to the surface that we just ground, and it is. We want to take our stub end bond, and in my opinion, this is the easiest weld we make. Now slip it into your side there. I should point out on the stub end bond, there's a flare. That's for positioning in the mold. So when your weld metal comes down, it's going to penetrate 100% of those strands, and it's going to penetrate only a given distance into the rail. Again, this is an engineered system. I neglected to say, before we make our Cadweld connection, if this bond has been sitting in the warehouse for a number of months, it might have gotten a little oxidation on it, but it's always good practice to clean it up a little bit with a hard cloth brush, just to get rid of any of that oxidation or contamination. Then you're going to want to insert it into your rail or your mold. And it's only going to push in so far because of that flare. That flare is very important. Now the operator is going to be able to stand back from the reaction. As I mentioned earlier, there's a trigger. pull that trigger, and it starts the reaction. But if a guy's just walking by, as soon as I let go of this trigger, the whole reaction stops. So that's very important. You can see with the lighting, and there's your reaction. Pull this off. Now this is a mistake a lot of people make. They pull this off the rail too quickly and they have molten metal fall on the ground. That's not good. So you want to wait 30 seconds, a minute. I pretty much wait till the red glow goes away. Then I disconnect my clamp. And this is pretty important, more important with the C-bond, but you want to pull straight back. And that's your connection. Beautiful. This dark material at the top, that's called slag. If you want, you can leave it. It's cosmetic. You can get a hammer, you can tap the nugget. People talk about, how do I test my Cadweld? Well, there is an electrical test, or you can pull it. Many, many years ago, guys used to take a 4-pound hammer and they'd smack it. We don't recommend that, because if you don't hit that nugget and you hit that rail, you can actually crack your rail. So we don't want you hitting that nugget with a hammer. Oh, that's beautiful. That guy knows what he's doing. Our next connection, Mike Spicola, our guy with 47 years experience, is going to demonstrate, is a straight splice. In this case, it's going to be our 500 kc mil stub end bond to 500 kc mil Ropelay cable. When you're using Ropelay cable, you require a sleeve. So first thing Mike's going to do is he's going to preheat his mold, which we've already preheated. He's just going to show you how to preheat for demonstration purposes. I'm going to ask a trivia question while Mike is preheating a mold. When we preheat the mold and we preheat the rail or other connections, can anybody tell me, you sir, Rodney, at what temperature does water boil at? Brilliant, Rodney. If I had one, I'd give you a vol cap. The reason we preheat a mold, is because if there's moisture present anywhere and you're hitting this with 4,000 degree weld material, molten, two things could happen. Number one, you get a very exciting reaction. Again, we want to stress, use those mold tops. Those covers are there for your safety. But the second thing could happen, it could actually give you porosity in your nugget, in your mold, your weld. This is an electrical connection. So when power or electricity passes from point A to point B, less resistance means better flow. And that's what we're trying to achieve here. So after Mike has done his preheating, and we've already cleaned the cable like we did in our last connection using a card cloth brush. Now we're going to insert these conductors into our mold. Now this is where instruction prints, again, are very important. With each new mold, you get an instruction print. Most people, as soon as they open up the box, it's going to blow away. But it's very important that you have these things. So consult your mold tag. It's going to give you the specific instruction print number, which you need. So give us a call. We'll email you a copy, we'll fax you a copy, we'll Pony Express you a copy, whatever you want. But it's very, very important that you have those instruction prints. Because some straight splices, when you put them in the mold, they might require a 1/4 inch gap, an 1/8 inch gap, no gap at all. So it's important that you have those instruction prints. So Mike, if you want to put those conductors in the mold.
Okay, on this mold there's no gap recorded.
All right. Mike, mold tag, what size weld material does that take?
Okay, this takes a PB200 or PB200 plus F80.
Man, that's brilliant. At your age, you can still read. That's awesome.
Read.
So in traditional Bluetooth, like Mike said, we have a PB200. We also have this available in Cadweld Plus PB200. But for this mold, For this connection demonstration, we're going to use traditional.
Okay, so what I'm going to do is place my mold on the sleeve, and again, the flare will dictate where it actually stops.
Mike, while you're doing that, let's say a sleeve comes off the cable. How far should I push on my new sleeve?
Basically, your sleeve should be down 1/8 or 3 millimeters from the end of the conductor. So that positions everything in the mold and allows it to be properly positioned. Once I have that, basically I'm going to check it. I look down the tap to make sure I see both cables under the center of the tap. And what I'm going to do is place my disc in the mold. All this does, it acts like a valve. It covers that hole in the bottom of the crucible called the tech hole. Next thing what I'm going to do is open up my weld material. I'm going to pour a little bit, and I'm going to watch it and make sure no hourglassing occurs where weld material leaks under the disc. Once I'm assured that happens, I'm going to dump the rest of my material out. Okay, as we stated before, there's a starting material in the bottom of the tube. I'm going to tap this. I'm going to place a little bit on top of the weld material. I'm going to close our cover. I'm going to place the rest of it on top of the cover.
So Mike, am I correct that those covers are pretty important for safety?
They're very important for safety. It directs all the flash and fire and brimstone away from the operator. So once that's done, I'm going to step out of the way and I'm going to ignite my weld. And again, per our instructions, you want to let it go for about 30 seconds. You'll see it glowing inside. Once that glowing subsides, you can go ahead and open up your mold. I think it's close enough. You see the slag is still a little bit kind of cherry red. That will tap off after this connection cools. And you have a homogeneous bond between each cable. That connection will carry more power than the actual cable itself. It will never loosen, never corrode. May not come off with this. There we go. Beautiful connection. Restaurant quality. Perfect.
For our last connection, our last rail connection, we're going to demonstrate called the C-bond. In this case, again following ARIMA recommendations, this is a 250 KC mil cable, and we're going to put it within the confines of the splice bar. So first thing you want to do is you want to use the proper bond with proper mold, proper application. So we're going to take our C-bond, we're just going to clean it up because this has been sitting around for quite a while. And it's always a good practice to clean it up, make it a nice active surface, wanting to accept your weld. All right. And after that, when you get a new mold, I did show you this earlier, put it up against your rail, and you want to put it as low as possible on that rail head. But different splice bars have different configurations, so watch this. Some of them actually be angled at the top, so when you put on your mold, you kick out the bottom. So you got to watch for that. You want to make a good solid connection between your graphite mold surface and your steel rail. So you want to push it down as far as possible. These are your adjustment screws. Okay. Once you have this adjusted properly for this size rail, every time you make a connection, you're not going to have to fiddle with it anymore. Unless you're going from a nice clean rail like this to a worn rail, then you are going to want to readjust. So please pay attention to that. So after we adjust our mold, we cleaned our conductor. We want to grind our rail. Where's my grinder? Excuse me. My grinder is right here. you want to grind your rail where you're going to be welding. Similar to the previous rail, you must use an approved grinding wheel, which are offered by ERICO. These rails are made for cutting and grinding. If you have another grinding disc that you want to use, feel free, send it in. We'll evaluate it for you. If you get a disc when you bought this grinder, those discs are made for metal shaping. We don't want to change the profile of this rail. We just want to clean the surface. This wheel is designed to erode before you compromise the integrity of your rail. Beautiful. Next thing you want to do is preheat your mold and your rail. Again, we talked earlier how water boils at 212 degrees. This weld material gets over 4,000 degrees. So what happens to water when it sees that type of temperature? It's going to want to boil. So that could give you an exciting reaction. Make sure you use these lids. They're there for your safety. Or it could become porosity in your weld. Porosity affects resistivity, so we want to eliminate all porosity, so get rid of that water. So I've already preheated these molds, but just to show you how it's done, I start from the cavity section and work my way out. I want to preheat my mold, or rail. Now, something that we did not show earlier, when I preheat, like I said, the purpose of this is to drive off the moisture. So how do I test that? What I normally do is I take my glove, my hand, now, even though this is a hot day, I don't know if the camera picked this up, you can see moisture moving away from where I'm welding. So again, to test the preheat, I put my hand away from where I've been preheating, and I run it towards where I preheated. If it's getting hot to the touch, I know I'm good. I'm warm. The other reason we do that is if I put my hand right where I worked so hard to prepare, there's oils and greases in your hand. You do not want to contaminate where you just worked so hard to prepare. Also the web. If I'm preheating the web, we didn't explain this earlier, I put my hand away from the weld on the back on the web. I run my hand towards where I preheated. If it gets hot to the touch, I know I'm good. So the next thing I want to do, in our procedures, I failed to mention, because this rail's in pretty good shape, but as a standard practice, if you went to a rail and there's all these oils and greases, you want to clean it off with a non-petroleum based solvent. Something as simple as a Windex is fine with us, but you want to check with your property to see what's approved. Believe it or not, Windex is not approved at every property, but you want something drying without leaving a film. So after you've preheated everything and you grinded everything, you're going to put your mold on there. Now, it's very important, you want to inspect to make sure you have a good connection between your graphite surface and your steel rail. These molds are good for about 50 connections. So let's say you've used your mold quite a bit and you think it might leak a little bit. you want to get what we call mold sealer. Just a moment. We sell mold sealer, and it's about the consistency of a silly putty, if you will. It's a flour-based material, and you can form it into anything you want. A lot of people just put it on the outside of their mold. It's just additional insurance from leaks. The molds we've been using today are pretty new, so we haven't had to use mold sealer. Before you do any weld connection, you want to inspect your equipment. If that mold's chipped or anything like that, you want to get a new mold. You don't want to try and use a mold that's no good, because if you have a leak or you have some other problem, it's very difficult to make another connection. So the old adage, penny wise, a pound foolish, it's very, very true in this case. So we're going to be demonstrating Cadweld Plus again. And if you look at your mold tag, it's over here, sorry. It says PB90. It takes 90 grams of weld material. Again, this welder is 13 inches long. It holds a 13-inch C-bond. It holds both the right and left at the same time. If you're going around a curve or worn rail to new rail, you might not be able to line that up perfect. These welders also come individual right hand and left hand. Again, Cadweld Plus, the operator is able to step back 6 or 15 feet from the reaction. Hold in the button, build up charge. And that's your reaction. That was number 1. Just pull this off. Fire in the hole. That's connection number 2. Now this actually works out very well. You see, when you remove this welder from the connection, it's very important that you pull straight back. So I'm sure you've all dealt with salesmen before, and you've noticed how wise they are. We come up with all kinds of inventions. If you'll notice, there's a little hole here in the welder. That's called Red's hole. Red was a salesman for ERICO many years ago. So after you open it up, your reaction's finished. You want to unclamp it, and you want to pull straight back. So you can put your cleaning tool or a screwdriver or something down this hole. It's called Red's hole, and you want to pull straight back. The reason you want to do that is because if you rock up and down or back and forth, it's only a 1/4-inch piece of graphite down here. You're going to snap it right off, and that's going to become a very expensive one-shot mold. That mold should last you for many, many connections. So that's your connection, and we're going to knock off that slag. Thank you for your time so far, but as you notice, we've come in from the outside to our Cadweld lab where we do much of our quality testing. But I wanted to review. Today we reviewed safety procedures, which are most important. We reviewed procedures for making a Cadweld connection to the head of the rail. We reviewed procedures for making a Cadweld connection to the web of the rail. Should you have any additional questions, don't hesitate to contact your sales representative and he'll be able to answer anything you might have. Thanks for your time.